Intro. Scientists claim that the universe began with an event known as the Big Bang, which occurred roughly 13.7 billion years ago. But the lingering question is, what triggered that explosion and why did it happen? Over time, we've delved into the science and history of our universe, and the Big Bang theory has stood as the primary explanation for the phenomena we've observed. Numerous studies and countless scientists have worked on gathering research, and the collected data consistently supports the Big Bang theory as the principal explanation for how the universe came into existence. According to this theory, dark energy, a form of energy that is even more prevalent than galactic energy, is seen as the anti-gravitational force that has been driving the universe's expansion ever since the Big Bang. Science today is vastly different from what it was in earlier times, and with advances in technology, new theories emerge. Many times, we find that what we previously thought was entirely true is not the case at all. Makaku has even proposed the formal debunking of the Big Bang theory, partly because the James Webb Space Telescope has detected 750 new galaxies that look completely different from what scientists had expected. This discovery presents a fresh perspective, encouraging us to investigate how the James Webb Telescope is reshaping our comprehension of the entire universe. Join us on this exciting journey beyond what is the observable universe, and let's explore the newly discovered galaxies in greater detail. If you're keen on staying updated with the latest universe-related news, subscribe to our channel, like this video, share it to reach a broader audience, and activate notifications for new updates. The James Webb Space Telescope and new discoveries. The images of new galaxies taken by the James Webb Telescope are simply breathtaking. In just one picture, we can observe hundreds of galaxies, and the magnificence and grandeur of these photographs are truly remarkable. Yet what's astonishing to researchers is actually quite different from what might surprise the average person. While these are inspiring to the scientific community, they don't align with the expectations based on the current theories. In fact, the number of galaxies observed is much higher than anticipated. And these galaxies are unlike others in that they are smaller than expected and exhibit ages far more remarkable than imagined. These surprises are sparking a sense of alarm among scientists, with even an article beginning with the word panic in its title, underscoring the gravity of the situation. These galaxies defy everything that was predicted based on long-standing theories. For many years, scientists proposed the Big Bang theory as the central explanation for the origin of our vast universe. According to this theory, around 13.7 billion years ago, the universe originated from a mysterious cosmic event. However, the newly captured images challenged the long-accepted narrative of the universe's birth. The images from the James Webb Telescope are shaking our understanding of the universe's origins, particularly since they seem to contradict the Big Bang theory, which has been regarded as an unquestionable fact by most cosmologists. The galaxies seen in these images are surprisingly small, smooth, ancient, and far more abundant than predictions based on the Big Bang theory had suggested. The observed galaxies are also 2 to 3 times smaller than those captured by the Hubble Space Telescope, which completely contradicts the expectations set by the expanding universe hypothesis. According to this theory, as the universe expands, objects should appear larger with increased distance. However, the galaxies observed by James Webb appear to contradict that idea. Furthermore, the smoothness of these galaxies was not anticipated. According to the Big Bang theory, galaxies should display irregularities and structural variations due to the dynamics of their formation and evolution. However, the images show galaxies with unusually smooth structures, lacking the level of roughness and complexity that would typically be expected for galaxies of their age. This challenges the anticipated timeline for the formation and evolution of galaxies as envisioned in the context of the Big Bang theory. The singularity and cosmic expansion. In the early universe, all matter, energy, and the foundational elements of the cosmos were compressed into an extremely dense point known as the singularity. At this moment, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of the singularity is rooted in our understanding of physics, particularly in Albert Einstein's general theory of relativity. Within this singularity, all the matter and energy of the universe existed in a highly concentrated form. The incredible density suggests that an immense amount of mass and energy was compressed into an infinitesimally small space under immense pressure and density. In such extreme conditions, The temperature inside the singularity would surpass any imaginable or measurable temperature we can understand today. Within this hot, dense point was the very origin of everything in the universe as we know it. The singularity marked the start of the cosmos from which everything emerged. After the singularity, the universe began its expansion and inflationary period, which occurred over approximately 13.7 billion years, ultimately giving rise to the universe as we observe it now. The expansion of the universe started with a rapid, enormous burst known as cosmic inflation. During this phase, the universe expanded far faster than the speed of light, stretching space itself and pulling everything along with it. Cosmic inflation played a pivotal role in forming the large-scale structure of the universe, smoothing out irregularities, equalizing the distribution of matter and energy, and setting the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of its expansion gradually slowed. It is important to note that while cosmic inflation was a brief period of rapid expansion, the universe continued expanding at a measurable rate, a process known as cosmic expansion. Scientists have studied the evidence of this expansion, including the redshift of light from distant galaxies. Redshift occurs when light waves stretch out as the universe expands, shifting them toward the red end of the spectrum. 750 new galaxies and unexpected discoveries. During the expansion, all the matter that makes up the universe was compressed into an extremely small volume. It became apparent that matter could not survive in such a compressed state, so transformations took place as the universe expanded and cooled. In this early phase, particles like protons, neutrons, and electrons began interacting with light and energy, which played a crucial role in the formation of matter in the universe. During the first minutes following the Big Bang, this process, called nucleosynthesis, involved the creation of basic elements. Chaotic and disrupted galaxies formed by multiple collisions were expected to be observed, but the James Webb images present a different narrative. Instead of chaotic, colliding galaxies, the telescope captures well-organized, disk-like, and spiral-shaped galaxies similar to the ones we see in the present-day universe. This unexpected finding challenges the assumption that mergers are a fundamental part of galaxy evolution. If these galaxies have not undergone many, or any, mergers, it becomes unlikely that small galaxies would grow into massive structures as originally predicted. This suggests that these galaxies might have always been larger than expected. Additionally, the optical illusion predicted by the expanding universe theory, where objects appear smaller due to cosmic expansion, does not hold true in this case. Thus, many of the concepts we previously held to be true may no longer be accurate. The age and abundance of galaxies revealed by the James Webb Telescope also cast doubt on the validity of the Big Bang theory. The James Webb Telescope's impact on cosmology. The James Webb Telescope is equipped with filters that allow it to capture images in the infrared spectrum, which enables astronomers to analyze the colors of distant galaxies. By studying these colors, scientists can estimate the age of stars and galaxies. If you enjoyed this video, please hit the like button, share it with others, and subscribe to the channel to stay informed about our future videos. The findings from the James Webb Space Telescope, JWST, represent a significant leap forward in our understanding of the universe. Its ability to observe distant galaxies with unprecedented clarity allows scientists to gather data that challenges existing models of cosmic evolution. The JWST's sensitivity to infrared light has allowed it to peer deeper into the universe than ever before, revealing objects that were previously beyond reach. These discoveries are reshaping our understanding of the universe's early stages and forcing a re-evaluation of established theories like the Big Bang. What this means for space science. One of the key implications of these findings is the possibility that our understanding of galaxy formation and the early universe might need to be rethought. The conventional idea of chaotic, irregular galaxies evolving from mergers and collisions may not be as accurate as once believed. The smooth, organized structure of many of the galaxies captured by the JWST suggests that the process of galaxy formation could have been far more orderly than previously imagined. This raises new questions about the mechanisms that drive the formation and evolution of galaxies in the early universe. Another intriguing discovery is the apparent age of these galaxies. The JWST's observations suggest that some of these galaxies are much older than expected, which contradicts the Big Bang model's predictions. According to the Big Bang theory, galaxies and stars should have taken billions of years to form and mature. However, the images from the JWST suggest that these galaxies could be much older than anticipated, which challenges our understanding of the timeline of the universe's development. If these galaxies are indeed as old as the data suggests, it could mean that the formation of galaxies occurred much earlier in the history of the universe than previously thought. The presence of such old and well-formed galaxies so early in the universe's history is a major puzzle. It forces scientists to reconsider the processes that allowed for such rapid galaxy formation. Final thoughts and outro. In conclusion, the James Webb Space Telescope has already begun to challenge some of the most fundamental ideas about the universe. Its discoveries of new galaxies that defy the predictions of the Big Bang theory are forcing scientists to rethink everything they thought they knew about the cosmos. These findings are pushing the boundaries of our knowledge and opening up new avenues for exploration. As we continue to study the data from the JWST and other future missions, we may uncover even more surprising revelations about the universe and its origins. The journey of discovery is just beginning, and the answers to the universe's deepest mysteries may be closer than we think. The discoveries made by the James Webb Space Telescope, JWST, have opened a new chapter in the study of the cosmos. The level of detail in its images and data is extraordinary, revealing previously unseen aspects of the universe that challenge long-standing theories. These revelations suggest that the universe may have a more complex and multifaceted history than we have understood up until now. The JWST's capabilities allow it to probe deeper into space and time, unlocking the potential to answer some of the most profound questions in cosmology. One of the most significant aspects of these discoveries is the way in which they complicate the Big Bang theory. For decades, this model was considered the most reliable explanation for the origin of the universe. Yet the recent findings of galaxies that are older, smaller, and smoother than expected raise serious doubts about its accuracy. The fact that the JWST has uncovered these galaxies, which appear to be far more mature than anticipated, suggests that the processes that led to their formation might have occurred in a different way from what we've assumed. This directly challenges the idea that galaxies formed gradually over billions of years through mergers and collisions. The shift in cosmic understanding. The discoveries made by the James Webb Space Telescope have ignited a shift in how we think about the universe. Historically, the Big Bang theory has been the cornerstone of modern cosmology, shaping our understanding of the universe's origins, its evolution, and the formation of galaxies. The new images and data emerging from JWST challenge key aspects of this model, which has long been considered an irrefutable truth in scientific circles. The apparent contradiction between the theory and the observed data invites a broader discussion on how scientific paradigms evolve and how new technology can prompt revisions of long-standing concepts. In particular, the existence of such well-formed, mature galaxies from the early universe raises questions about the timeline for galaxy formation. According to the Big Bang theory, galaxies were expected to form slowly over time, shaped by numerous mergers and collisions. However, the observations from JWST suggest that the process may have been much faster and far more organized. This challenges the notion that galaxies gradually built up through chaotic interactions, pointing toward the possibility of a more orderly and rapid genesis. Furthermore, these discoveries shine a light on the limitations of current models that rely on the idea of a singular, uniform cosmic history. Traditional theories often assume that the universe expanded in a uniform manner, with galaxies evolving according to predictable processes. The JWST's findings suggest that galaxies may have followed a different evolutionary path, and that external factors like dark energy, previously considered to play a relatively passive role, might have had a more direct influence on their formation. Another exciting possibility emerging from these observations is the potential for deeper insights into the nature of dark matter and dark energy. Both remain largely mysterious, yet these findings suggest that the forces shaping the universe could be far more complex than currently understood. The idea that galaxies may have formed differently than previously assumed opens up the door to rethinking how we study and define cosmic evolution, and how we model the universe's ultimate fate. As researchers continue to sift through the vast amount of data collected by the JWST, it's likely that even more surprises will emerge, further complicating our understanding of the universe's history. we may discover that the universe's origins were not as simple as we once thought, and that multiple processes shaped its formation over a much longer span of time. As we gain a clearer picture of the early universe, our conceptions of cosmic evolution and the future trajectory of space may be fundamentally altered, revealing a far more intricate and interconnected reality than we can presently imagine. The road ahead for cosmology. The revelations from the James Webb Space Telescope have not only shaken existing models, but also sparked a renewed sense of curiosity and excitement within the scientific community. As these discoveries unfold, they encourage cosmologists to revisit and refine their theoretical frameworks, recognizing that the universe may not have followed the gradual, predictable path previously assumed. The potential for entirely new models of galaxy formation and cosmic evolution is now on the table, as scientists seek to understand the true mechanisms behind the creation of these early, well-formed galaxies. One of the most profound implications of this data is the potential for a more nuanced understanding of cosmic inflation and its effects on galaxy formation. The discrepancies between the Big Bang model and the latest observations challenge the assumption that the early universe was a chaotic, irregular place. This suggests that future research may reveal a more orderly process of cosmic evolution, with certain unknown forces or processes driving galaxy formation in a way that was previously overlooked. In the coming years, as astronomers continue to study the images and data captured by JWST, the field of cosmology will undoubtedly experience a paradigm shift. These findings may not only revolutionize our understanding of the early universe, but also redefine the way we approach questions of cosmic origin and the nature of reality itself.